I can see your screen.
Now you can see my screen, right?
No, not it.
Okay.
Yeah.
So now decode. So decode is I want to implement a logic like, okay, for example, I have a data, right? Select star from department. Select star from EMP. This is my employee table. Whenever I'm executing this query, so I'm getting okay. So whenever I'm executing the select star from employee, see here the department number is 20, 30, 30. This is the just example only. Okay. So I want to print like this. 1 second.
Okay.
Sabran garu నేను క్లాస్ లో ఉన్నా మళ్ళీ చేయనా సార్ ఓకే okay so I want to implement a logic like this. So if department number is equal to 20,
What are getting something in the bedroom?
okay, I want to print 20. So whenever the department number is equal to 20, I want to print 20. Okay, so if department number is equal to 30, so then I want to print 30. Okay, I want to print 30. So if department number is equal to 40, I don't have the 40 but that's fine, is equal to 40, so then I want to print 40. Okay, else if anything other than 20 and 30, I want to print as others. So how can I do this type of logic in SQL? Okay, in PL SQL I can use this if statement, but in SQL how can I use it? We can use using a decode function, or we can use a case expression. Okay, we can use either decode or case expression. So how can I use a decode? Okay, let's see. Decode function start. Okay, so what I want 20. Sorry, the first column what I want to compare the department number.
Department number.
20.
Okay.
So then use 20. Okay, if 30, so then 30. So 40. Okay, so else final others. From here. See here 20, 30, 30 and 10 is others. Simple thing is whenever I'm using the decode, when department number is equal to 20, then display as 20. Okay, if is equal to 30, then display 30. If 40, display 40. So if 10, 20, okay, if it is not equal to 20 or 30 or 40, then display as a others. Okay, the decoding. Okay.
Okay.
Clear?
Yeah.
Okay.
Yes.
So now let's see. Anybody have any other issues or any other doubts? Sorry, yesterday I did not get a chance to send that functions. Today I will be sending. Anybody have any?
Roll up the time. Can't be able to see the screen. Can you explain one more time?
Let's see. Select department number, comma job, comma count. Okay. Department number, job, comma count from employee. Group wide, department number, comma job. I want to display this output. So what is the functionality of this query? This query calculates number of employees from employee table, group by department and job combination. So it's calculating.
Yeah.
So 20. Let's see. Let's put it this in the order. Okay, so 10 clerk, 1 employee. 10 manager, 1 employee. 10 president, 1 employee. Okay, so 20, 2, 2, 1, 30, 1, 1, 4. This is the group by. I want to do more analysis on this one. I want to extend the results of group by. Okay, using either roll up or cube. Roll up. don't need to change much. The only thing is I'm adding the roll up. Let's see. This is the output I got it. So now see here, 10 clerk 1, 10 manager 1. So the total 10 how much? So now it's again aggregates at one level of department number. 20 and total 20 how much? 30 and total 30 is how much? So total 40. So it's extending group by. So with a normal group by, I'm not going to get this record, I'm not going to get this one, and I'm not getting this, and I'm not getting this one. So I have 13 minus 4. I will be getting only 9 rows. Okay, when I'm using the group by with the roll up, I'm going to get the more details. Total how many at the department number level. Shalini, clear?
Yes, sir.
Okay, so now the further extension of the roll up is cube. Cube will give you more number of rows because the roll up will give you the combination of count based on these two columns and further aggregation only on the first column only, not on the job level. But here the cube will give you all possible combinations. See here, 10, 10, 10. So the total is 4. So the total 10 is 3. And the total clerk level also 4. See, here clerk 1, here clerk 2, and here clerk 1. Total clerk 4. And total 10, 3. Total 10, 3 and total clerk 4. That means the cube will give you some more analysis up to all possible combinations, aggregations. Okay, everybody? Everybody is clear? Anybody have any other doubts, please? Okay, let's see. What is a table? So we have seen the complete select statement. Select from where group by having order by. And we have seen and all SQL operators. And we have seen what else we have seen? And functions. Okay. Functions also. So now let's going back to another category. Okay. So now what is a table in Oracle? What is a table?
Rows.
Rows and columns. So the table is a database object. It contains rows and columns. Okay. Everybody is not able to hear me? Everybody is able to hear me?
Yes.
It is a database object with rows and columns. Okay. So the rows contains the data. And column describes the characteristics of the data. Columns describes characteristics of data and table, characteristics of a table and data also. Okay, so let's see. So now how can I see the structure of a table? How can I see the structure of a table? What is the command we can use to see the describe command? The DESC and EMP. The simple DESC and EMP. It will give you structure of a table. The describe EMP. Okay, so now here I will be getting this information. Let's see what is this and everything. Okay, let's see. This is the structure of employee table. Okay, so now how many columns are there in the employee table? Employee number, e-name, job, manager, hire date, salary, commission, and department. Okay, and we have a type. The type of a column is nothing but the data type of a column. The type of, we are going to see the data types of a Oracle. Today we are going to see the data types of a Oracle. Okay. Now the type indicates the data type. Column describes the characteristics of data. What is the characteristics of a data? Mainly column characteristics. One is type of data it accepts, and amount of data, maximum amount of data we can store. We can store in a column. See the column characteristics. It displays the column. Column describe the characteristics. Okay, let's see employee number. For example, here employee number. Here employee number is a column. Is a column of EMP table with number of 4 as data type. This is my question. So what is a number and what is a 4? Okay, so the number means number is it accepts only numerical digits, numerical values. Only it accepts numerical values. Okay, the number data type. I'll explain what is the different data types. Okay, the number is a data type which accepts only the numerical values. Then what is 4? Okay, so the 4 means 4 nines. This is the maximum number we can store. We can store in table. So that is the maximum number we can store in this employee number column. So that is the maximum number we can store. Okay, the number of 4 means only numerical value with a maximum of 9999. That is the maximum number we can store in a number of 4. So number of 3 means 3 nines. Okay, number of 5 means 5 nines. Okay, everybody, this is just example. I will explain what is the different data types we have. Okay, so before describe EMP. The describe EMP will give you all the columns along with their data type and the size. So the size is the maximum amount we can store. Okay, so now here we have seen number, varchar2, number, date. But what are the all possible data types in Oracle? Data types of Oracle SQL. What are the data types? Okay, the following are the supported data types. The first one is number, and second one is the character, and third one is the varchar2 or varchar. Okay, fourth one is date and timestamp. Okay, club. Okay, and XML type. Okay, raw / lambda, lab and club. See, these are all the possible data types supported in Oracle. So the number data type, character data type, varchar2 data type, date data type, timestamp data type, lab type, club type, XML type, lambda. Okay, so this one. So the long, let's see the description of a number. Number is for storing numerical value. Whenever I want to create a table in future, we are going to create a tables in future classes. Whenever you want to create a table with a salary as a number, so we need to salary. Salary means the type of data we can store in a salary is a numerical data. So the numerical data in the sense is we can store in a number column is for storing numerical value. Okay, numerical values, only numerical value, and it can store both positive and negative number. It can store both positive and negative numbers. That means we can store both positive and negative numbers. Okay, so what is the syntax of using a number? What is the syntax? How can you define a column type in a table creation? Okay, column name, comma, number of P, comma, S. Okay, P, comma, S. What is P and what is S? I'll do. So S is optional. So here S is optional. That's why I'm putting in the square brackets. If I put anything in the square bracket, that's optional. Okay, so here S is optional. Okay, P stands for precision and S stands for scale, precision and a scale. Okay, so the maximum value of P is 38. Max value for P is 38. That means in a Oracle data type number, we can store up to 38 nines. That's not a single number. That's not easy to fill up that number. That the P is the maximum 38. Okay, so scale. What is the use of scale? That is for storing decimal values. That's for how many decimals you are going to store. Okay, for example, let's see. Okay, column name is the salary, number of 7 comma 2. Okay, total salary 7 comma 2. 7 comma 2 is, okay, what is the maximum number we can store here? The total is 7 nines. 7 nines. Out of the 7 nines, 2 nines are for decimal values. The total number, the total maximum value. We can store in number of 7 comma 2 is this number. Total 7 nines. Maximum value we can store in the number of 7 comma 2 is this one. So it includes both positive and negative number. S is an optional. Okay, so commission is number of 4. That means the maximum value we can store is 9. Okay, see the simple. The number is for whenever you want to create a column with a number type. Simply you can use the number with a certain precision and scale, with a P and scale values. Okay, P stands for precision and S stands for scale. Okay, everybody, number. So that's the very thing is this number of 4 and this number of 4 and this number of 7 comma 2 and this is the number of 2. That is the maximum value we can store. Okay, everybody, is it clear? Yes or no, please. Just ping a message. Is for storing alphanumerical values. Alphanumerical values, that is both numbers and characters. So the character, we can store characters and numbers. We can store both characters and numbers also. So that means for storing alphanumerical. So the number is only for storing number characters only for number. Okay. So now the syntax is, how can I declare a syntax? Is any column name character of 5. Sorry, character of n. Here n is the maximum number of characters we can store. Here n. N is max number of characters we can store. Maximum number of characters we can store. So what is the maximum value of a n in Oracle? So the max value for n in char is 2000. That means we cannot store more than 2000 characters in this data type. We cannot store more than this many number of characters in this type. So for example is, okay, gender, character of 1. So only one character. Okay, job, character of 10. So the maximum number we can store is maximum 10 characters. Characters can be stored, both numbers as well as characters. It can be stored, both characters can be stored. Maximum 10 characters can be stored, which includes both numerical and non-numerical values. Okay, I'll come back to character again. Okay, so now, so the varchar, I'll come back to the character once again. Okay, so is for storing Alphanumerical values. What is the disadvantage of character so far? What is the disadvantage of character? What is the disadvantage of character?
I think even though you need it or you don't need it, still whatever you mention in the character value, that will
That's
store in
fine.
the
That we will discuss. Other people doesn't know that one, but so far, what is the disadvantage of the character? That's right. Okay, but see the maximum is 2000 only. We cannot store more than 2000 characters, right? So how can I store more than 2000 characters? Okay, we have to use the varchar. Shavani garu meer cheppina answer correct. Okay, syntax is column name and varchar2 of n or varchar. So here n is maximum number of characters we can. So max number of characters. So the maximum value for n is 4000. So that means even is varchar2 is also for storing only 4000 characters. Okay. So now the description. Varchar2 of 100. Okay, so then why we have a two data types for the characters? One is character and another one is a varchar. Okay, the first, why we have to use a varchar2 rather than character? First question is, if you want to store more than 2 characters, we can go with the varchar2. If you want to store any value with more than 2000 characters, the first option is we can go with the varchar2. Then, why it is a varchar? Var means a variable character length. Variable character. So varchar stands for variable character. So the char is a fixed length. Okay, let's see. Let me explain the difference between both character and varchar. Okay, I'm defining a character char of 5. I'm declaring a variable a. I declared a variable of varchar2 of 5. Okay, so a is a character type. And here b is a varchar type. Okay, so now I'm assigning a is equal to xyz. I assign xyz, and similarly b is equal to xyz. I assign a is equal to xyz and b is equal to xyz. Okay, so what is the maximum value we can store in a? What is the maximum number of characters we can store in a? How many?
5.
5. And similarly, the maximum number of characters we can store in B is also 5. But we are assigning only 3 characters. But how internally Oracle stores? Okay, so I'm giving only 3 characters. But Oracle stores, can everybody put it in mute, please? Okay, Oracle stores in database as X, Y, Z, space. So fixed character. So internally, so the total size occupies on database is 5 bytes, 5 characters, because we defined it as a 5. That means if we give any value less than 5 characters, so the remaining characters will be appended by space in character database. Whereas, so here Oracle stores in database as XYZ only. There is no extra spaces will be appended in the varchar. Whatever you give, only that much space will be utilized. Total size occupies on database is 3 bytes. Okay, where character is a fixed length and varchar2 is a variable length. So in the character, we are going to waste some memory because it will append some spaces. But actual number of data we are giving here is XYZ. But it stores in a 2 spaces here because it's going to waste a memory on the database. Everybody is clear? So the main difference between character and varchar2 is, okay, so in the character, memory waste will be there. In the varchar, there will be no memory waste. No, period doesn't count in the value for a character number type. See, the number storage is different and varchar storage is different. Number, that is the maximum value we can store. It's not the number of characters. See, in the number field, that is the maximum value we can store. Here, in the character and varchar, the max number of characters we can store. That is the difference. Here is the value talking. Here I am talking about the max number of characters we can store. Okay, everybody. So this is the basic difference between character and a varchar. Okay, varchar2 and varchar both are exactly same. Okay. So now, everybody is clear the difference between character and a varchar. The character is a fixed length. Varchar, it's a variable length. Fixed length means it occupies only that many number of characters only. Varchar2 is a variable character. It won't waste any memory. Date is for storing date and time. Both. In yesterday's class, we have seen a toChar function to get the time. So in a date column, we can store both date and time as well. The date and time. The complete date and time up to seconds. Okay, complete time up to seconds. Is for storing date and time up to seconds. We can store. The syntax is, there is no size specification for this one. Any column name, date, that's it. Any column name and date. For example, okay, date of birth, div, date. Date of birth, date. Simple. Okay, the day which can store for both date and time. There is no maximum size because we are going to store a complete date and time. By default, date column stores time also. The timestamp is for storing date and time up to milliseconds. The difference, milliseconds along with time zone, EST or CST or PST. The server date, server where the server resides, that timestamp will be stored up to milliseconds. Milliseconds mean how many precisions we want to store. That will be stored in this data type, the timestamp. Okay, so the difference between date and time is the date stores both date and time up to seconds, whereas the timestamp stores for date and time up to milliseconds. Not only seconds, so we can store up to milliseconds along with the time zone, EST or CST or PST. Okay, everybody. Column name, timestamp. That's it. Timestamp we can store. Okay. Okay. So now, so what is the disadvantage of character and varchar? What is the disadvantage of character and varchar? What is the disadvantage of a character and a varchar? What is the disadvantage of a character and a varchar? Anybody? The simple one, right?
Character, it takes only 2000 2,000
2000.
characters, and the varchar is takes the 4,000.
4,000. But how can I store the photo? Okay, so now for example, I want to store my PDF document. I want to store a movie in my database table, column name. I want to store a photo. How can I store all these things? That means the size of the document is more than 4 GB. Sorry, more than 4,000 characters. So now is for storing large object, either structured or unstructured data. Structured or unstructured data. Okay, so the structured data means I want to write my story. I want to write one story in a normal English, the structured data. Unstructured data means like a photos, movies, something like a scanned copies or images or something. Okay, those type of information can be stored in database using lab and a club. The lab stands for something like PDF document or movie or photos. Okay, so the lab stands for large objects. Okay, club stands for character large objects. Large objects and character large object. So this is for unstructured data. This is for completely structured character data, character large objects. Okay, characters can be stored, but what is the maximum size we can store? We can store more than 4 GB of data. We can store more than 4 GB of data. In the recent versions of the Oracle, we can store up to 22 GB in a single column also. We can store 22 GB also. Okay, something like a PDF document or movie, structured or unstructured data, lab or a club data type. Because when we have to use a club, whenever we need to store a more than 4,000 characters, we can go with a club type. Everybody is clear how to use and everything we will see during the table creations. These are very important because starting from tomorrow we are going to see data insertion, data update and data delete. Before inserting data we need to know the data types of a table. That's why I'm giving the data types. Okay, so the XML type. Anybody have any idea on the XML document? Is for storing XML documents. XML files in a database. Is for storing XML data. Okay, now the syntax for this one is there is no size. Syntax for this one is column name lab, column name club. Simple. There is no size because both stores the more than 4 GB of data. That is the maximum we can store. Okay, is for storing a XML files in database. XML files. What is the meaning of XML file? XML file is some kind of mechanism for communicating between the two servers. So the XML file, it looks like a text file, similar to a text file, notepad file with a proper format. But this one is very important. I'll give you an example when I'm discussing that one. I want to show you what is an XML file, what is XML tag, how it looks like and everything. Okay, but right now in today's class point of view, XML type is for storing XML files in a database. That's it. Keep remember this point. Okay. Now, so raw and long raw is for storing, okay, structured and unstructured data. is for storing structured or unstructured data, long and long run. Similar to club and lab only. Okay, so now something like PDF document. And one thing is, never ever use these columns. Note, this is at all not required. Never ever use these data types. Never ever use these data types. The maximum, just I'm doing this complete Oracle completely deprecated these data types because it has a lot of disadvantages. So the club and club is the advanced versions of the long and longra, because long and longra, the only 2 GB amount of data we can store. Only 2 GB amount of data we can store. We cannot store more than that one. Okay, restrictions we have. And the second one is, we cannot have more than one column of type either raw and wrangler. So only one column per table. We cannot have more than 2 longra columns. This is, forget about the long and longra. Never ever use it. And we cannot create any indexes on these columns. Indexes will improve the performance, the data retrieval. Okay, indexes we will discuss in the another type of database objects. Okay, we cannot create any index. We cannot create primary keys on these one because these are the completely deprecated. Never ever use these data types. If anybody asks you, can I create a table with a long and longra? That means we can create, but it is not good. Oracle is strongly recommending never ever use these data types. This is a completely deprecated. Everybody is clear? These are the data types. What are the data types we have? We have number, and we have character, and we have varchar and varchar2, and we have date, and we have a timestamp, and we have a lab and a club, XML type, and a long and a long row. Okay, everybody is clear, or anybody have any doubts, please? Anybody have any doubts? Yes or no?
No.
Okay, now let's see one more topic. These are very important while doing the insert operations into the table. Okay, now let's see. Now, okay, the describe EMP. I'm executing the one more time, describe EMP. Let's. So here it is saying not null. EMP number is not null. What is this not null? Okay. So what is this not null? Employee number is not null. That means, okay, so during the table creation, we are declaring that employee number is not null. Employee number column is not null. See, the not null employee number column of EMP table is not null. What is the meaning of a not null? Okay, so what is not null first here? Here, what is not null? Okay, so what is the significance of not null? Here, not null, that means, this means we cannot have a null in employee number column of employee table. We cannot have a null. For example, let's see here. So I'm deleting this 7934. Let's see, null. Here, cannot update employee number to null. Cannot update employee number to null. That means I'm telling that Oracle that employee number is not null. That means during your insert operation, okay, we cannot have a null in employee column of employee table. Okay, during your insert or during your update operation, we have to give some value. We have to give some value to employee number because we define it as a not null. If you declare a column as a not null, that means for every row of the table should have some value. Okay, so can I say it as a rule? Can I say it as a rule? Not null is a rule. Not null. So I'm saying not null. Basically, I'm saying not null is a rule defined on EMP number column of EMP table. What this rule will do? This rule makes sure some value during insert or update operations. It makes sure some value in the column. Right? Is everybody is okay? Everybody is accepting to this line. So I'm saying, okay, the not null is a rule defined on employee number column of employee table. What the rule will do? So this rule makes sure some value in the column during the insert or updation. If a rule fails, okay, if you violate a rule during your operations, during your insert or update operations, update means existing data, operations, so then Oracle fails that operation. So it won't allow you to finish that operation. So it makes sure the data in a table should have some value. Is everybody is okay? So the not null, if I declare a column as a not null, what is the meaning of a not null? Not null is a rule defined on a column. What the rule will do? It rule makes sure to have some value. So Oracle should not violate that rule. The data what you are giving into that column should satisfy that rule. Everybody is okay? Everybody is okay? Yes or no, please, everybody. I want yes or no from everybody. Shravani Garu.
Yes, sir.
Shalini, Harita.
Yes.
Okay. So if you violate that rule, Oracle makes sure you have some value in that column. Okay. So let's see. So now I'm saying it is a rule, but Oracle point of view, I cannot say it is a rule. Okay. That is called as a rule in Oracle point of view. So here I am saying a rule, right? Rule in Oracle point of view called a constraint. Is a constraint. What is a constraint? The constraint is a rule on a table columns. Okay. So the constraint is a rule. So here it is what is not null. Not null is a constraint. Now I'm changing back to is a rule. Rule in the sense is a constraint. Is a constraint. In the bracket rule. Defined on the column. This constraint make sure have a during the operation. Okay, rule in Oracle point of view is called as a constraint. The constraint is nothing but a rule or a condition. Either a rule or a condition. Either a rule or condition. What these rules or conditions will do? This will make sure or ensures that the data what you are inserting into the table should satisfy all the constraints. Okay, not null is a constraint. That means the data what you are inserting into the table should satisfy that constraint. Okay, so the data what we are. Okay, and think it's a constraint. Okay, we can have any number of constraints. Constraints on a single table. We can have any number of constraints. Okay, in this table only one not null by looking at this one, but we can have any number of constraints. Okay, so we have to the data what we are inserting or updating should satisfy all constraints defined on the table. All the constraints should satisfy on the table. We have to satisfy all the constraints on the table. If any constraint violated, your insert or update operation is going to fail. If you violate any one constraint, if you violate a constraint in the sense violates, so then your insert or update operation is going to fail. Not only update, DML operation is going to fail. So if you violate any constraints, then your insert or update operations is going to, we can have any number of constraints defined on a table. Okay, so what are the types of constraints it supports? Types of constraints supports. We have only 5 constraints. Not null constraint, okay, and unique constraint, primary key, foreign key. Okay, let's make it check constraint and foreign. These are the 5 constraints we can define on a table. So the today's class only theory of the what is the definitions of this one, how to implement these constraints we will see in a table creation, because these constraints are very important for your insert or update operations. Okay, so now the not null constraint. What is not null? The not null means we have seen. What is the not null? If we define a not null constraint, specify the column does not accept the null values. Not null constraints, column should have some value. If we declare a column as a constraint, if we declare a column as not null, that means that column should have a null. See here. Okay, so clerk, I am removing the clerk. See, it is null. Yes, the operation completed successful because the job column accepts null, because I did not created the not null constraint on the job. I can have a job. See here. Job can accept a null, but employee number cannot accept a null. Everybody is clear? I'm changing back to clerk. Everybody is clear? So if you declare a column as a not null, that means that column should have some value. We cannot have a column with the null. Okay, everybody is clear?
Yes.
Okay, so now what is unique? Okay, unique. If you declare column as a unique, if you declare a unique constraints on a column, constraint on a column, okay, on a column, we declare a constraints on a column. That means, okay, the first point is, okay, we can insert null into the unique column. It can accept null values. We can insert the null value, null into unique column. And the second point is, no two rows of the table have same value. No two rows of the table have same value in unique column. Unique column. That means the number is unique. See, can a two persons have the same employee number? Can a two persons have the employee number same?
No.
No, it is unique. Unique means if I have a million rows, but if I declare a name as a unique, no two persons, no two records have a same value. That means it is a unique. And one thing is, we can insert a null into column. So the unique constraint, we can have a, if you declare any unique constraint on a column, then that means that column inserts a null into unique column. We can insert a null into unique column, and no two rows of the table have the same value in the column. That's a unique value. Everybody is clear? The difference between not null and unique. Not null means compulsory we have to value. The value can be a duplicate. Not null column accept the duplicate, but unique column it does not accept the duplicate because the value is unique. Everybody is clear? Now, so now.
Only check in the description, right?
Sorry?
On the table, I didn't see the unique specified, like.
I don't have the unique in my table.
Okay,
it's not
so
required.
Then why it is not taking in the EMP table? We didn't declare that unique constraint is there. So why it's not accepting the
unique constraint is there? I will show you. That's the implementation part. Don't go into the implementation part. Okay, it's already there a constraint. Okay.
Oh, then the description we can't see.
Here it is not seeing the constraint, but we have a constraint. If you see here, it's the constraint is there. See, it is the PEMP is the primary key. Let me explain that one. Okay, constraint is there.
Oh, okay.
Okay, constraint is already there, but the description is not showing the constraint. Description is showing whether it is a not null or null, and along with the column and the data type only. Okay, so now the primary key is simple. Not null plus unique. Not null plus unique. What is the difference between unique and primary key? Unique accept null values and primary key does not accept null values. Okay.
Combination of two.
Combination of two. Not null plus unique. No, it's very simple. Primary key is a not null plus unique. Now, see here, the check constraint is, okay, the check constraint means, so the column value checking against a expression. Column value, if we declare a check constraint, column value checking against an expression or a set of values. Or a formula, or a value. For example, okay, so I'm declaring gender. I'm declaring a column. Let me explain this one. Okay, this is little bit gender. Okay, character of 1. Check gender in this one. Here I defined a column, gender column, with a data type character, and I am defining a check constraint. Check gender in M and F. So this means this column gender accept only values either M or F. Okay, this definition means so we can insert only M or F in gender column only. So I am restricting gender column to some value. Okay, second example, salary number of 7,2 set salary greater than 2500. So that means the syntax may be little bit different, but an example. Okay, this means so the salary column value should be greater than 2500. Every time if we give any value less than 2500, we cannot insert. So the gender is expression or a formula or a value. So this is the check constraint. The check constraint is to validate a expression against a formula. Everybody is clear? So the not null, unique, primary key and check constraint. The final one is a foreign key. Foreign key is for implementing relationship between two tables. Relationship between two tables. That means for implementing a parent-child relationship. Parent table and parent-child relationship between two tables. I'll explain this one. Between two tables. The parent-child relationship between two tables. So the foreign key is for implementing a relationship between the two tables. Okay, let's see. I have employee table here and I have a department table. Okay, so now can we have an employee without working in any department? Can we have an employee without working any department in a company?
No.
See here. So we cannot have an employee no. Okay, let's see. Okay, so now here, can I insert, can I insert employee working in department number, working in department not exist in DEPT table? Can I create an employee in XYZ department, but XYZ department is not in? Is it possible?
No.
Right. Say we have to allocate employees to only existing departments only. We have to allot employees to existing department only. I can recruit an employee, I can put it on bench for some days unless I find a vacant position in any department. I can wait for a department. So the couple of days he can be an ideal. He can belongs to company, not belongs to specific department. If I'm giving to an department, he should be in a particular department. Okay, here which one is the master table or which one is the child table? So into which table we have to insert a record? So do I need to create a record employee first or department first? EMP or department? What is the parent table in this one?
Employee.
Employee is not a parent, right? How it is employee is a parent? First department is my parent table. See, first I have to create a company. I have to divide my company into departments. Then I recruit an employees. Okay, see the department is the master table here. right? Why I am saying it is the department number is the master table? Because so the master table, so first I create an employee, first I create a company. Okay, company have departments and departments have employees. So what is the hierarchy? What is the hierarchy here? Company, department and employee. So first company, then department and then employee. So now in this hierarchy, company is a parent table. Here company is a parent. Parent of company is a parent of employee or company is a parent of department? Department. So department is a parent of EMP. So EMP is a child. So whenever I am creating, so how the tables is going to create? So the company ID column in the department table, department name column in my employee table. Let's forget about this company. I don't have the, okay. So now here, see here, I have a department table here. Sorry, department table. I have a 4 records. 10, 20, 30, 40. So I have only 4 departments. Okay, in my employee table, this one, 14 rows, because all the department numbers is belongs to this one. A child table. Okay, let me see here. I'm deleting 30 and I'm giving to 60. I'm giving to 60. Okay, so how the foreign key will work? I have a foreign key relationship between these two. So now I'm saving. It says that parent key not found. So I'm trying to insert a department number 60 in my employee table. What Oracle will do? Whenever you are inserting a data into child table, in employee table, immediately Oracle validates the value what you are giving in the foreign key column, that is the 60 here, in his parent table. What is the parent table of an employee for the department number column? Department table. Immediately Oracle validates in the department table, do we have 60 in my department table or not? If 60 is not there, immediately Oracle will not allow you to insert a 60. See the foreign key. What the foreign key will do? Foreign key will check it. Values against the parent table. Whatever value you are giving in the child table, that should be available in the parent table. That should be available in parent table. If the column is not there, value, then it gives an error. See here, I'm giving 30, 10, 20, 30. I have 10, 20, 30. That's fine. 40 in the department table, but not in my employee table. That is fine. Because I can have a more department numbers without an employee. That is fine. But I cannot have an employee in a department which is not existed in the department table. So the foreign key implements a relationship between the two tables. We need to identify what is the child table, what is the parent table. Here in a child table, department number has a foreign key to parent table department. What is the column name? It is associated department table. Everybody is clear? Everybody is clear the definition of a foreign key. Foreign key is for implementing a relationship. While inserting a data into child table, we need to have a corresponding record in the parent table. Okay, and one important point is, for a foreign case, on a parent table, it should be a unique or primary key. and a parent table, okay, unique or primary key only. See here, okay, in my employee and DEPT table, I'm deleting this one. In the employee and DEPT table, the foreign key constraint is between employee number, department number. Foreign key always creates on the child table. Foreign keys creates on child tables. Foreign keys always creates on the child table columns. For these columns on the parent tables, it should be a unique or primary key. We have to see in the employee table. In the employee table, I have a foreign key for the department number. So what is the parent table? Parent table of this table is DEPT. In the DEPT, the department number column should be a primary key or unique key. Everybody is clear? And foreign key. Sorry? Yeah, go ahead, please.
In the child table and in the EMP table, is it necessary for to having like primary key or unique key?
In this department number column?
Do we have to create primary key or?
On what columns I'm asking? Do you want to create a primary keys on the department number column?
Yes.
No, right? Because in the child table, department number repeats, right?
Oh, okay.
We cannot have a unique or primary key, right?
But from primary key is a combination of not null and unique, right?
Combination of not null and unique, but unique is also unique. I cannot create a unique on the department number, right?
Okay.
See, what is the meaning of primary key? Primary key, combination of a not null plus a unique. Not null means compulsory we have to give a value, and unique means it should not be duplicate values. I cannot create a primary key and department number because the department number is repeating, right? In a child table.
So we don't need to create any constants on that.
Foreign key, you have a foreign key, right?
Only foreign key. But the parent table should have a primary key or else unique.
Or unique. Because in the parent table, this column should be available in only one type.
Unique, yeah, right.
Okay, in the child table, in the parent table, it is only one record. In the child table, we can have a multiple records. That's why one-to-many relationship.
Okay.
Okay. And one important point is foreign key columns accept null values. Foreign key columns can accept null values. That means I can have a null in this one. Foreign key columns accept null values. Foreign key columns accept null values. That is fine. If you are giving any value, that should be in the parent table. That should be in the parent table. So the only thing is the parent key and what is the parent table and what is the child table. In a child table, we will create a foreign key to parent table. On the parent table, it should be a primary key or unique key. Okay, and foreign key column. Foreign key columns in the sense is in the child table, it can accept a null values. Okay, so what is the use of this foreign key? Foreign key is to implement a relationship between two tables. So whenever we need to use of foreign keys, okay, so whenever we need to write a query, whenever we need to write a select statement, select for getting data from more than one table, okay, for more than one table, so then we have to use this foreign key, use these foreign keys. Foreign keys for joining two tables. Okay, so in the tomorrow's class, we are going to write a select statement to get the data from multiple tables. Whenever we are getting the data from multiple tables, we need to join those tables using these foreign keys. The foreign keys will help you to join two tables. Okay, everybody is clear? Foreign key accepted. Can I insert a null into foreign key? Yes, we can insert a null into foreign key. But if you are giving a value, that value should be in a parent table. That value should be in a parent table. Everybody is clear?
Yes, sir.
Super. 1 second, please. So today I am stopping here. So let me stop first recording. And everybody is clear, or anybody have any doubts?